Okie dokie. So standard deviation, here we go. This normal curve is representing a lumber company that claims to produce 8-foot long boards. So the actual board length is normally distributed with the mean of 96 inches. So that's the average, and it's going to deviate by 2 inches. So here we go. Dragged the dashed red line on the graph to show at which board length approximately 16% of the boards are produced are going to be longer. So here's what we know. There is two standard, let's see, 96 to 98. Standard deviation is 2, so that's the first one. 34% of the data is there. 34% of the data is there. Okay, now if we keep going, if we break down 2 standard deviations away from 98 to 100, that captures 13.5% of them. And then 100 to 102, that captures 2.35, and then 102 beyond captures 0.15. So at which point shows that the board length, 16% of the boards are longer. So if you add the 13.5 to the 2.35 to the 0.15, if you add these three together, 5, 10, 15, oh, hold on, that's not right. You're going to get 16. So where's the decimal? There's the decimal, so I gotta add these two together. 5 and 5 is 10. 5, 6, 7, 8, 9, 10, 13, 14, 15, 16. So there we go, 16%. So you have got to drag your dotted line right here. So 16% of the data is to the right of that dotted line, which means the boards to the right, these are getting longer and longer. Okay, number 2. Leanne's been keeping track of the number of book pages she reads each night. She realizes the number of pages appears to be normally distributed with a mean of 17. So the average is 17. And it deviates by 4. So if we go 4 above, and 4 above that, and 4 above that, and if we go... Okay, so the question, what percent of the time is she going to read 21 or more? So from this point, 21 on. Okay, 34% is between the mean and the first deviation. We just did this, it's going to be 16. 13.5 is there, 2.35 is there, and 0.15. If I add those three up, they give me 16. Okay, number 3. Abigail, Brett, Chris, and Devin want to make sure the number of cubes they're using for the board game are fair, so they each take a cube and roll it several times, and they're keeping track of the number of times that a 1 is rolled. Here are their results. So Abigail, she rolled only 5 times. Out of those 5 times, she got 3 1s. So 3 out of 5, she is rolling 1 60% of the time. Brett, he rolled 50 times. 30 out of 50 is also 60%. Carissa, she rolled 60 times, 12 out of 60. That's going to be 20%. And then Devin rolled 34 out of 30. That is 13%. So, whose dice is most likely flawed? And that would be Brett's. Because Brett rolled 60% of the time he rolled a 1. So you should roll 1 out of 6. The chances of you rolling a 1 are like 17%. So Devin's pretty close, Chris is pretty close. These two are way off. It's got to be something close to 17%. Abigail's off because she did not roll very many times. Brett, he rolled 50 times, so his dice is definitely jacked up. Normal distribution. What percent of the data falls within one standard deviation of the mean? So here's the mean. One above and one below. That'd be 34 below, 34 above. So you gotta mark 68. 5. Okay. So you've got some results from drug A and you've got some results from drug B. And which statement might appear? They're talking about the mean. I think we just gotta find the average. Mean. Okay, we gotta find the average. So drug A, 410. So I'm just going to add them up. 4 plus 10 plus 6 plus 2 plus 11 plus 9 plus 2 plus 7 plus 6 plus 10. And I get 67. And I'm going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the mean is 6.7 plus 9 plus 3 plus 7 plus 3 plus 5 plus 10 plus 6 plus 2 plus 1 plus 3 plus 4. Okay, and there are 72 divided by 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Divide that by 15. 72 divided by 15. Okay, 4.8. So the average on drug A is higher. So the average of patients treated with drug A is greater than the average of patients treated with drug B. Okay, I think that's the one. The average of patients on drug A is greater than the average of drug B. Okay, number 6 gives you a box and whisker. Okay, box and whisker, here's what it does. It takes and divides your data into 4 groups. So 25% of the group is there, 25% of the group is there, 25 is there. So it takes and divides whatever you got into 4 groups of 25%. So that's all you really gotta know. Each group is represented with exactly 1/4 of the data. So here we go. This drug company is developing a new cold remedy. They ran trials on 4 remedies. Test subjects were randomly distributed among 4 groups. Each group received 1 of the 4 remedies. Subjects were asked to rate relief symptoms on a scale from 0 to 10. 0 is sucky, no relief, and 10 is awesome. Okay, so based on the results, which remedy showed the most? So we need most of the data saying there was some kind of relief. Okay, so here's what we're going to mark. Okay, D is kind of out of the question. So here's 5. 5 means maybe halfway. So between 5 and 10, you'd think those scores would be good. They show promising relief, and all of your data is from 0 to 5, so D is no good. And this little guy's an outlier. So there was one of the candidates that said that was about an 8 or a 9, but everyone else said below 5. So this little dot's an outlier. This dot's an outlier. Where's the average? Right here is the average. So let's look at C. C, dun, 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 you have So that's a quarter of your group is right there. But then you've got, let's see, you got 3/4, so 75% is below the average, plus some of this 25, because some of the 25 is above. I think probably B is the most promising, because check out B. B, here's your average, and you're capturing about 50% of the patients say that it was effective. And C, you're not capturing even a quarter. D, you capture nobody. A, you capture a fourth, and then maybe a half of that fourth. So B is where you're capturing most of the data that says it's good. Okay, 7 is the same as the dice one. Which data is jacked up? If you go 3 out of 5, 60% of the births are girls. 4 out of 5, that's 80%. 12 out of 20, that's 60%. And 16 out of 20 is 80%. So you look at the ones with the high percentages, 80%, you're going to look there and you're going to look there, and the difference between these two, this hospital only had a total birth of 5 and this one had 20. So this is the one that's skewed, because the more births you have, the closer it should get to a 50-50 shot. But if you only have a 5, that's a pretty small sample, and anything can happen with 5 births. You can have all 5 girls. But the more bursts you have, the more it's going to get closer to 50%. 8. A report claims that the GPA a student earns in high school is a predictor of that GPA the kid will earn in college. Which one supports it? It is C, because they are tightly grouped together. And as your high school GPA, so if you got a 4.0, that's this line right here, that matches up with a 4.0 in college. Phone survey times are normally distributed. The average is 15 minutes. So if we go 15 minutes and the standard deviation is 5, what percentage of the phone surveys take between 5 and 15? So I'm going to go this way. 10, 5, 0. Okay, so this is the average right here. So 34% of the data is there, and 13.5% of the data is there. So we're going to mark C, because they want to know between 5 and 10. It's going to be 34 plus 13.5. Let's see what we got here. Okay, same thing. Study conducted. The average farm size was 40, so that's the mean, 47.1. Deviated by 8.6. Determine the range of farm acreages that covers 68% of the farm. So I need to go one above and one below, because that's 34% there, that's 34. That will capture 68% of the farm. So if I go one higher than the average, that's going to be 47.1 plus the standard deviation, 8.6. So that's going to be 55.7. If I go one below, it's just going to be 47.1 minus 8.6. And that's 38.5. So 38.5 to 55.7, that captures 68% of all the farms. Okay, 11. Which one shows an average of 5? So this guy or this guy, and a standard deviation of 2. It's going to be C. Count by 2, 7, 9, 11. This one only counts by 1, 6, 7, 8. Okay, last one. 350 kids at Jowell's school. He surveyed a random sample of 50 kids and found that 32 play a sport. So 32 out of 50 play a sport. 23 out of 50 play an instrument. And 13 out of 50 have a job. So, using his sample, how many students would you predict play an instrument? So that's these guys right here. So 23 out of 50. 23 out of 50 is almost half. That is 46%. So if 46% of his sample played an instrument, let's say that 46% of his school, which is 350, will also play an instrument. So of his times, so 0.46 times 350. So probably close to 161 kids